I'm Mark Sponsler, and welcome to the Stormsurf Video Surf forecast for the week starting Sunday, June 12th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we see a gale in the Tasman Sea producing up to about 30-foot seas, just barely in the Fiji swell window, and there have been seas larger earlier, all radiating off to the north, targeting Fiji, in fact arriving probably pretty soon, and eventually pushing towards Hawaii. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough that is a push in the jet to the north. We see it right there. In fact, Australia's there, New Zealand there. This is the Tasman Sea here. You see this trough touching the southern tip of New Zealand. What this does, and you see the winds flowing like that, it helps create a clockwise flow aloft and down the ocean surface. That's the hallmark of low pressure in the southern hemisphere. And of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface, create seas. Seas, if they're big enough, start radiating away from the fetch area and eventually moderate, turning into swell. Swell when it hits your beach turns into surf. So it all starts with a trough. We have a good solid trough. It's actually been over the Tasman Sea for several days now, generating seas, and we'll get into that in a minute. But it's starting, at least it appears to be starting, to move to the southwest Pacific. East of New Zealand, you see the trough pushing south. This is called a ridge, and all that does is support high pressure aloft and down at the ocean surface. Does nothing for generating swell. So right now, the greater Pacific, locked down by high pressure, low pressure, in the Tasman Sea, starting to radiate towards the southwest Pacific. This is good news. And as we get into Monday, here we go. The trough actually gets free and clear of New Zealand. Not a huge trough, not with piles of wind energy pushing into it, but a trough nonetheless. Circulating pretty good as we get into Tuesday with winds in the about 110 knot range, something like that. You don't need that much wind in the southern hemisphere for whatever reason to get support gale development. And then as we get into Tuesday night and Wednesday, the trough starts moderating, moving further across the southwest Pacific, but winds a lot weaker, maybe not so conducive to gale development. And and eventually, as we get into, well, here we are Thursday and Friday, the trough looks like it's going to try to reorganize a little bit. And there we go, as we get into Friday night and Saturday, looking pretty solid, but I think there's also a ridge starting to push south at the same time. A little bit of a battle of uncertainty as to what's going on here. Earlier runs of the model, actually this trough looks much better than it did on earlier runs of the model today. So here we are, almost a week out, Sunday, 6Z, and if you are to believe, as we get into 12Z and 18Z, a very solid trough is forecast. Now, as I'm saying, this morning, none of this was on the models. We're a week out. I wouldn't believe it, but this looks actually fairly epic if it were to come to pass. Theoretically, starting Sunday, a week from now, potential strong storm development in the southwest Pacific, but we're not holding our breath. All right, so let's go down to the surface. Surface level pressure, surface level winds. Let's see what effect the jet stream has on what matters. It's wind blowing on the ocean surface, not up at 30,000 feet, down, physically imparting energy to the ocean. That's what generates swells, and that's what generates surf. So we have a gale low, 972 millibar, maybe 970 millibar, just starting to get clear in New Zealand, generating 30 to 35 knot winds in the Tasman Sea, but no fetch aimed off to the northeast, east of there. And another little gale south of Tasmania. The two of these together are supposed to make something pretty interesting. And there we go into Monday. You start seeing 30, 35, 40, 45 knot southwest winds starting to get traction and then covering a broad area. Now, yeah, there's 45, almost 50 knot winds down in the south end of this gale, but they're all aimed off to the west, maybe back at New Zealand or Tasmania for some sort of a strange back angle swell there. But it's this fetch here that we're interested in targeting the U.S. West Coast as we get into Tuesday. Look at this, and some of this is starting to be drawn up as we get into Tuesday. 45-knot winds from the southwest. That looks real good, covering a broad area, aimed, we'll say at northeast, but it's almost east-northeast, so maybe not as potent as it looks, but at this point, anything's a good deal. Yes, we had a good run of surf, but now we're kind of in the doldrums. This is still 3 or 4 days out from forming, and it would be a week after that till it hits to Hawaii, so it's almost 2 weeks out from the U.S. West Coast. So, again, take it with a grain of salt, but looking pretty good. Additional fetch continuing to Wednesday night and Thursday. Kind of peters out. This was supposed to do something on previous runs of the models. Now it looks like it's falling apart. But then as we get into Saturday and Sunday, this new trough tries to get organized. We'll see. Here we go. Actually, some good solid fetch here. And look at this up in the Tasman Sea. Australia, Fiji, that area would be going out of their minds if this really develops as forecast. And then we get to 180 hours out. Lots of potential if it holds true. So we're going back a week in time. This is significant wave heights for the South Pacific Ocean. Hindcast going back in time, 0 hours. This is the ground truth, or at least the best estimation of the ground truth of what has happened recently. And as we get into, I believe it was Wednesday, there we go, Wednesday into early Thursday, the gale started building in the Tasman Sea, 23-foot seas, building to 26 feet, and then in about the 24-foot range on Friday. And then it built again with 30, I think we got up to about 30, there we go, 32, 33-foot seas right there, 33-foot seas. Oh yeah, you check the script out here. I know most people don't care. 43.25, we were rounding this off and it was getting us some weird numbers, so we went and fixed all the scripts, at least for the broad patches of the ocean, so you can get it down right now to the 1/4 of a degree. Perhaps only myself would appreciate that, but it's there just the same in case you're interested. Those seas faded. Here we are, current time, Sunday, 12Z fading, another gale building. Let's go look at the future. All right, looking forward, and the small little gale, yes, this will produce swell for Fiji and New Zealand and maybe Tasmania, but really it's when it starts integrating with what's left over of the Tasman Sea gale on, we'll say Tuesday, we start getting seas in the 35-foot range. They combine together 38-foot seas, building to 40 feet over a tiny area, aimed reasonably well off to the northeast. That's Tuesday afternoon. Still solid into Wednesday morning, 35-foot seas, and then fading from there from about 30 feet on Wednesday evening. So Tuesday, Wednesday, not too far off. Reasonable chance this will develop. Of course, you got to watch the models, make sure what really happens. Things, I don't even believe a model on the details 3 days out. What the 0-hour hindcast is what you need to watch to make sure you know exactly what is going or what is coming for that matter. Now, secondary gale possible on Sunday, but it is, oh, now here we go. This is not looking as strong as what we saw on the previous chart in terms of what one would have expected for sea heights, but still, we'll see. Give it a week. Something looks possible. Wind swell generation potential for Hawaii right there and the U.S. West Coast. Right now, light winds in California, but there's a front here pushing into Cape Mendocino. There's actually low pressure here. That's going to be clearing out shortly. And the northwest wind machine driven by this high pressure, La Nina-induced high pressure system in the Gulf of Alaska takes control. And as we get into Monday, 25 to 30 knot north winds along the north and central California coast. Trades, not too bad for Hawaii, in about the 15 knot range. So you get into Tuesday, more of the same. Wind machine, northern central California. Good for making wind swell, but really sloppy conditions. East trades for the Hawaiian Islands. East facing shores probably getting some wind swell. Wednesday, things moderate some along the California coast, but due to another little tiny low pressure system here pushing towards the Pacific Northwest, winds down to 15 to 20 knots near shore, wind swell fading off some. Trades moderating for the Hawaiian Islands. Thursday, Well, here we go again. There's northwest winds. Next low pushes in, and as sure as that happens and the low moves, the wind machine will probably start up again for California. Trades continue. Look at this good solid fetch of east trades. 15 knots for the Hawaiian Islands. Good for wind swell production. We get on Saturday, 20-knot winds along the north and central California coast. Trades for the Hawaiian Islands. Just a broken record. Sunday, pretty much the same deal. No real change. So basically, wind swell and winds for north and central California. Trades and trade wind swell for the east shores of the Hawaiian Islands. Hikers forecast for the Pacific Crest Trail along the spine of the Sierra. No snow expected. Freezing level, well, dropping down to about 10,000 feet on the 13th, that would be tomorrow, and then building warm again, high above 14,000 feet. This is the freezing level, and then finally falling again on June 17th, 18th, and 19th in about the, we'll say 12,000 foot range, and then back up, typically above 14,000 feet is what you'd expect during summer months. So moving into a more normal summertime regime. All right, let's go take a look long term. What's going on with the Madden Jullian Oscillation, that periodic weather oscillation that goes from west-east around the planet on the equator, and the El Nino Southern Oscillation, currently in the La Nina phase. So first up, we look for signs of the active phase of the MJO, the Madden Jullian Oscillation. There are two phases, active and inactive. The active phase is like a low-pressure system. It feeds energy to the jet stream when it's over the Pacific, specifically over the West Pacific. Also can reverse trade winds, which can take warm water in the West Pacific, start pushing it east in the form of a Kelvin wave. Successive active phases of the MJO over the West Pacific, if they're strong enough, can create successive Kelvin waves, and that can help usher in El Nino. And of course, El Nino sets up low pressure over the Pacific and is great for storm production, swell production, and rain and snow in the Sierra. All right, so we're looking at winds on the equator. The West Pacific here, East Pacific here. This is the equator. Date line at 180. That's New Guinea there. We're just looking at the arrows. Winds pretty strong. Oh, this is data from the TAA buoy array, series of buoys strung across the equator used for monitoring El Nino. Arrows pretty strong out of the east, meaning strong east winds in the East Pacific. Strong east winds in the Central Pacific. Hawaii would be right about there, but up off the north end of the chart. And over the all-important Kelvin wave generation area. This is where, in the West Pacific, when the active phase over here, this is where you generate Kelvin waves. Winds moderately strong out of the east. But it's not the actual wind speeds. It's the differences from normal for this time of the year. They call it anomalies. Looking for the arrows to go east or west, we see none of that, meaning these winds are pretty much normal for this time of year. Look in the Central Pacific, maybe a little bit stronger out of the east, but not much. And in the all-important Kelvin wave generation area, winds a little bit stronger out of the east. All right, if the winds are reversed even a little bit or even dead neutral, that's a sign of the active phase of the MJO. But we're not seeing any signs of that. But the good news is we're not seeing any significant strong sides of the inactive phase of the MJO either. And that really steals energy from the jet stream and dampens storm production. So not too bad a situation for the moment. Let's go take a look a week out. All right, here we go. Zonal wind anomalies. That is wind the east-west. Zonal is east or west component of the wind. The yellows, reds are the west component or the east and west component of the wind. The west component, the reds and yellows, are the active phase of the MJO. The blues, east anomalies, the inactive phase of the MJO. Now, this is the whole planet on one chart. This is what's been happening in the past. Where are we? And this is the forecast here. The date line's right there, right up the middle of the chart. The far West Pacific starts about 135 east, so about right there. Kelvin wave generation area ends just east of the date line, 170 west. So just in this box right here is the forecast. All we see is blues. They are trailing off to the east. So this suggests inactive phase of the MJO building for the next 1, 2, maybe 3 days, then starting to slide off to the east and maybe moving out of the Kelvin wave generation area a week or so from now. And you can kind of look back here for the past month and just see preponderance of east anomalies, inactive phase of the MJO, most of that driven by La Nina. Little smattering of westerly anomalies here back in late May, early June. That was probably the active phase of the MJO. This pink line, there was just a data outage. There was no data forecast, so there you go. But anyway, you can still get a pretty good idea what's going on and what's to come. Let's look further out. Next up, outgoing long wave radiation. That is fancy words for more cloud cover or less cloud cover. Yellows, positive anomalies, more sunlight bouncing off the ocean surface, more reflectivity. That means high pressure. That means the inactive phase, the MJO. And as expected, yeah, active phase or inactive phase in control right now. Maybe hanging on for another 5 days, 10 days outgoing completely neutral, 2 weeks out, still neutral. This per the statistic model. The dynamic model suggests, well, maybe the inactive phase a little bit stronger and holding a little bit longer out about 10 days, so a week and a half, and then finally fading out. So not too big of a difference between the two models. Phase diagrams, another way to look at the MJO. This is consider the MJO moving on the equator from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot right there, that's where the active phase is. So in the far west Indian Ocean, maybe over Africa, and the further the dot is out away from this circle, the stronger it is. So a very weak active phase in the West Indian Ocean. And here's 3 different projections from the statistic model of where it's going to be, roughly over the Maritime Continent 2 weeks from now, and exceedingly weak. The dynamic model basically has the active phase, getting a little bit stronger over Africa, kind of collapsing, meandering over to the mid-Indian Ocean, still very weak and just doing nothing. So neither model really suggests any hope for the active phase in the next 2 weeks. Looking further out, this is the upper level model, 200 millibar level. Propensity for precipitation. The green's favorable for precipitation. That would be the active phase of the MJO. The yellow, not favorable, dry air, the inactive phase. This goes out 40 days, 5 days each panel. South America, Central America, the equator right there, New Guinea there, so the date line would be roughly about there. And you can literally see the propagation from west to east. This would be the inactive phase, making its way across the Pacific into Central America on June 27th, with the active phase moving into the West Pacific on June 22nd, making its way across the Pacific through about mid-July, and then another inactive phase following behind that. None of them looking particularly strong, just moderate strength at best. And then the CFS model going out a month, all right? Same deal, whole planet on one chart, but this is 850 millibar wind, so closer to the surface. The reds and oranges are westerly anomalies. That would be the active phase of the MJO, and you can see the solid black contour. That is the active phase moving across the Pacific. In fact, there's the date line running right up the middle. Far West Pacific at 135 east, so about there. The cool box, or the one we're interested, Kelvin wave generation area, right in about that area to 170 west. You can see in the past, active phase, this was in March, early April. Dotted contour, inactive phase in the blues, easterly anomalies. Another weak active phase, tried to see 1, 2, 3, kind of just connect the lines. And a little bit of westerly anomalies here in the late May time frame. Inactive phase, and there's the inactive phase building now in the West Pacific. Consider pretty much the whole month of June with the inactive phase in control. Now, the inactive phase doesn't mean that there's not any storm production. It just dampens the potential some, steals some energy from the jet stream. And so the latent potential energy is not there as much as when the active phase is crossing the Kelvin wave generation area. And then finally, the 3-month CFS model. The forecast is on the top here. This is what has happened in the past. Again, whole planet on one chart. The blues are easterly anomalies, reds and yellows, westerly anomalies. We see blue anomalies, easterly anomalies, the La Nina signal locked over the date line since February, pretty much this whole past winter. We've gone through a pretty good spurt here of modest westerly anomalies. Then you see, moving forward, easterly anomalies setting up, but they're jogged off with their center about 150 west. And we see westerly anomalies forecast building, not in the Pacific, but right on the hairy edge, entering into the Pacific and making it to about right there. That would be about 150, maybe 160 east. So about, filling half the Kelvin wave generation area. Now, this is not El Nino. It's not even neutral, but it's a lot closer to being neutral. We'd like to see these westerly anomalies be sitting at about 120. When that happens, I think we're at neutral. That said, this we think is a precursor to what is better things to come. We're going to get into that in a minute. There's the interaction. It's the mixture of the atmosphere and the ocean working together. The ocean can actually draw these westerly anomalies out across the Pacific, and then when they do, they influence the ocean. Then the ocean reinforces what's going on in the atmosphere, and they start a cycle, and they start working together, and then they build into something. We've been in a negative cycle where easterly anomalies over the dateline have fueled the development of cold water over the Pacific, which in turn shuts down evaporation, which builds high pressure over the Pacific for the past 2 years. And it sets up your classic La Nina sort of pattern. We think we're on the cusp of that changing, and you're going to see why in a couple of minutes. Anyway, let's continue on. Overlay, the MJO. All right, the dotted contour, inactive phase of the MJO. So that's supposed to be setting up now into about, mid-July, something like that. Active phase sets up, builds some west anomalies. They push to almost the dateline, but not quite. And then they kind of hold there, and we kind of linger in the same sort of pattern. Let's overlay the low pass filter. This is the high pressure, low pressure bias. The dotted contour, again, the high pressure bias with two contour lines. That second contour line getting ready to shut down here in about a week, centered roughly at about 150 west. And then as we move forward, the second contour line comes back later in July. Forecast holding, maybe jogging off to the east just a little bit. The low pressure bias, which is your El Nino indicator, still firmly over the maritime continent. Strong second contour building sometime in late July, early August. We think with a little bit of luck and a little bit of drawing from the Pacific Ocean, that might start easing its way off to the east as we get deeper into fall. But this is early in fall, September 8th. So still, the atmosphere, according to this model, thinks we're going to be in La Nina, but we think that's going to be pretty short-lived. All right, so we talked earlier about the ocean influencing the atmosphere and the atmosphere influencing the ocean. Here's where things are starting to get very interesting, and a trend appears to be building. Not so obvious here, so we'll start with the basics. Subsurface water temperatures. West Pacific here, East Pacific here. These X's are the anchors on the TAA buoys array. The X's themselves are the sensors. These are the anchor lines, I'm sorry. The X's are the sensors. Take the data from the sensors, feed it up to a central computer, use a model to fill in the gaps, and you get a profile of subsurface ocean temperatures. 29-degree isotherm, moving just to about 171, 172. I think it was over at 174 or 175 east last week, so it's backed off a little bit. The 28-degree isotherm holding pretty stable, somewhere around 177 west, something like that. The 24-degree isotherm at 130 west, moving west a little bit, and the 24-degree isotherm right into Ecuador. But it is the anomalies, differences from normal for this time of year. Now, this model's been, the data and this model have been overhyping the extent of the warm waters, or at least so we thought. 3-degree anomalies, well, where's the dateline? Let's get that in our brain right here. So it's right about there. Warm waters in the West Pacific, that's unquestionable, but this model has been consistently showing some thin little stream of warm water and building warm water off of Ecuador, and other models have been saying that's kind of nonsense, but this model is now hyping it more and saying there's a full-on flow of warm water pushing to the East Pacific. Now here's where things start getting real interesting. This model, the higher res model, was showing, no, the warm waters were only making it to maybe 150, but all of a sudden this week with this update, now it's showing a full massive amount of warm water pushing the whole way to 140 west, that's past Hawaii, with a finger making it almost to the equator, almost reaching the surface to a point south of California, and the last little bolus of cold water hanging here, trying to hang on off of Ecuador. This is a lot of warm water, and it is on the move, and it's hidden from view at the ocean surface. But it is there. When even the most conservative model shows it in place, and we have some more data to support this, this is a very good sign. All right, sea surface height, sea level anomalies. That is, the sphere of the ocean. Is it higher or lower than normal? We have Chile, Peru, Central America, Baja, Hawaii right there, equator right there, dateline right there, New Guinea there. This looks pretty much the same as it's been all along with positive anomalies. Positive anomalies means the sea surface is higher than normal here, okay? Warm water at depth expands, creates a bump on the ocean surface. Cold water at depth contracts, creates a divot on the ocean surface. We have positive 5-centimeter anomalies there in the West Pacific the whole way to the dateline, and a finger just north of the dateline. What is this, maybe 2 or 3 degrees north of the equator, moving the whole way to a point south of California. Now, this model here is incorporating that data, also showing that finger reaching to a point south of California. This model, I think, is finally starting to realize that the anomalies on the previous chart here are a little bit more meaningful than they initially suspected. And look at this, 0 anomalies the whole way. Well, let's see, Ecuador is there, the Galapagos are there, minus 5-centimeter anomalies at about a point south of California. We had minus 15 centimeter anomalies over the Galapagos last week, and they were the coverage of 10 centimeter anomalies and minus 5 centimeter anomalies was much larger, contracting, meaning cold water is getting smaller here, also signaling this whole area under here is probably warm water, a massive Kelvin wave trying to push to the east. But is it a Kelvin wave or is it not? That's still part of the debate. Upper ocean heat anomalies, all right? This is just heat volume and where it's placed in the Pacific. West Pacific here, East Pacific here. We're going back a year, July. Cold water, La Nina, 1, 2, 3 pulses of like the inactive phase of the MJO just stirring up cold water. We got that Kelvin wave that pushed across in January, the whole across the Pacific. Cold water tried to get going again in the East Pacific, but has faded. And notice this, look at starting around last year, we've had warm water building consistently in aerial coverage, and this is just in the Pacific. This doesn't count what's going on over the maritime continent. There's a huge reservoir of warm water there that we think when the active phase pushes over, not quite Bali, but a little bit east of there, all that warm water eventually leaches through the maritime continent and bleeds out into the Pacific. We just haven't had a strong enough active phase of the MJO yet. The ocean and the atmosphere are not coupled. The atmosphere thinks we're in La Nina, but there's this massive buildup of warm water developing here. And we also saw, like right here at about 120 east, the low pressure bias is sitting there just pumping west anomalies over the maritime continent towards the Pacific, and you start getting this big buildup of warm water. And you can see it actually recently pushing off to the east to about 145 west now, so that's past Hawaii on the equator. And you see the extent of this cold water here in March and April slowly eroding, and even the cooler water here starting to show signs of weakness as if it's all just fading out. Again, we come back to this chart. Warm water steadily pushing off to the east. Looks like a Kelvin wave. Not moving fast enough to necessarily be a Kelvin wave. There hasn't been really any westerly or active phases, westerly anomalies strong enough to make it quote-unquote a Kelvin wave, but it appears like the dam is going to burst. At some point, the trades will just back off, and all this warm water is just going to come flooding this way, pushing the last of this cold water to the surface. And after that, La Nina is going to be over. Warm water will start blowing up, exploding to the surface off of Ecuador. And once that happens, all of a sudden precipitation will start over off of Peru in that area. And then the core of the Walker circulation, which is over the maritime continent, will start pushing off to the east, and the Pacific will quickly fade from La Nina into at least an ENSO neutral state. One more piece of data. Upper ocean heat anomalies. This is the upper 300 meters of the ocean. Last fall, cold water in control, right? And you can see from about November of last year, yeah, we got a peak of warming in February, cooled off, but as of today, we're dead neutral. Now, how is that neutral distributed? Again, this way. Warm water in the west, cold water in the east, but the warm water steadily pushing off to the east, suggesting there's a massive imbalance of pressure here. This side, at some point, is going to break through wherever the magic dividing line is, and it's all going to be over. It's just a question of when at this point. Now we go look at the surface, and it's the exact opposite picture, all right? South America here, Chile, Peru, Central America, Baja, Hawaii, the equator right here. The blues, colder, this is sea surface temperature anomalies. Colder than water normal, classic La Nina signal off Chile, Peru, the whole way along the equator out to the dateline and beyond. What's happening underneath all this is the exact opposite of what we're seeing at the surface. Now let's put things in motion, or put things in perspective. The oceans change first at depth. Then they manifest themselves at the surface. And once the surface changes, then the atmosphere above it changes. So what we're seeing, again, this large eastward moving pocket of warm water with piles of warm water backing up behind it are in direct contrast to what we see at the surface. And to put things in perspective, you go, well, there's cold water here, but that warm water goes to almost 120 east. In fact, the bulk of it is to about here. So this whole region down at depth is cooking warm water, cold water at top, with a finger going to here. There's the last of the cold water being pushed to the surface by that warmer water down deep, leaching to the surface, gets caught by the trades, blows out along here. But you also notice warm water starting to show up in pockets along the equator, and more so than last week. The question is, when will the warm water finally make it across the Pacific? When will the trades collapse? And when will La Nina fade out? Let's dig a little deeper. All right, sea surface temperature trend. What's going on at the surface? Well, we got warming going along Ecuador. We have a couple of stray little pockets of cooling, but kind of just a stable, if not slightly warming trend here right off of Ecuador. So no big signs of change at the surface, but we know we have in our back pocket that, so let's draw it here. Literally, this whole area going like to 150, so all this here is much warmer than normal water underneath, and that warm water extends to here. It just hasn't reached the surface yet. As soon as that does, this is all going to start lighting up in red. And then the backed off view, of course, colder than normal waters are little stray pockets of warm water, but at the surface versus what's going underneath, they are polar opposites of each other, and that is a good thing because that warm water is signaling the demise of La Nina and a return to at least ENSO neutral conditions. Sea surface temperature Nino 1.2 index is the water temps right there along Ecuador and Peru. Temperatures today still cold, 1.5 degrees, 1.501 thousandths of a degree below normal. The La Nina threshold, or to be ENSO neutral, is 0.5 degree, so we're well below that here. In the official El Nino region, the Nino 3.4 region, we popped up above the 0.5 degree mark for a day or two. We went down. Today we're at 517 thousandths of a degree below normal, so effectively right on the threshold. This is the first time we've been on the 0.5 degree line above it or at it in months and months and months. Still not, it's significant in that things are warming, but this is nothing compared to what we think is coming somewhere in the next few months. Sea surface temperature anomalies in the Nino 1.2 region. Now the previous chart we looked at says temperature is pretty much flat, but this one shows they're building still below the threshold. Here's the half-degree line right here, so not there yet. So there's a disparity in how this data is calculated depending on which site you go to. Nino 3 region, creeping up. Nino 3.4 region, creeping up, though in the 3.4 region, that other chart shows temperatures right about here, this one below, and in the Nino 4 region, temperatures creeping up. So some disparity in the data, but everything's showing an upward trend in temperature. So what does the atmosphere think is going on? Well, just eyeballing the sea surface temperature data, cold water across the whole equatorial Pacific, so one would say that the atmosphere thinks that La Nina is in control. Take a look here. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When pressure is lower in Tahiti, which is in the Pacific, the index goes negative. Darwin is over the Indian Ocean, effectively. When pressure is lower over Darwin, the index goes positive. Today, 8.58 positive, so still La Nina territory, or the inactive phase of the MJO. Just eyeballing down here for the past month, well, no real change. It maybe is dropping a little bit on average. In fact, the 30-day average takes some of the noise out at plus 14.51. We were up higher. I think we were somewhere around 20 there. You can see it a month ago. So slowly working its way down, but not significantly. I mean, we want to see this at least get to zero. That's neutral. The 90-day average is plus 16.20. Where have we been? Well, we've been almost, I don't know, I don't want to go 16.86 or something like that, maybe a little bit higher. So we're down off our peak. Now, let's be clear. The atmosphere is a lagging indicator. We talked about this before. Warm water building subsurface is the leading indicator. It erupts to the surface, and then the sea surface temperature anomalies will change. And then months after that, if the warm waters hold, the atmosphere go, hey, something's changing here. And then the jet stream will start reconfiguring itself. And you'll start seeing this Southern Oscillation Index value starting to fall. In fact, here's the 30-day moving SOI graphed out. Okay, you can see we were in the negative territory 2 years ago or more, 2.5 years ago. We've been positive ever since, indicative of La Nina. We're falling some, not enough to be really of importance yet because, well, the ocean's still quite cold. That reinforces high pressure over the Pacific, blah, blah, blah. Again, it's all, we see warm water at depth down in the ocean, but it's going to take 2 months to make it to Ecuador, right? And then it'll take time after that for the atmosphere to respond in kind. Let's go take a look at the forecast, though. Sea surface temperature forecast for the Nino 3.4 region, the official El Nino region. That's just water temperatures on the equator, 5 degrees north and south of the equator, from a point south of California out to about the date line. Today, June, somewhere in here, temperatures just about reaching the half-degree threshold, moving towards ENSO neutral. It's not a single-day reading. It has to go for like 5 consecutive months. So it's a lagging indicator. When someone officially declares, okay, we're out of La Nina and we're in ENSO neutral, well, odds are you've been there for quite a while according to some of this data. Anyway, sea surface temperature forecast, temperatures going up to about 0.35 or 0.4 degree below normal, falling back down in October, the final last pulse. It seems like La Nina goes in pulses. It was strong the first year, pretty strong last year. It's trying yet again in the fall, but you can see that somewhere along the line, that bolus of warm water we keep talking about, well, it's going to make its way across the Pacific. It's going to leach to the surface. It's going to start moving the whole way across the Nino 3.4 region. So we get into January, and we'll be in ENSO neutral. Theoretically, we'll be in ENSO neutral maybe starting in late November, something like that, maybe early December. And then it'll take another 2 months, something like that, 3 months for the atmosphere to really wake up. So maybe in the late January, early February time frame, La Nina, even in the atmosphere, might be gone. The jet stream will wake up. The storm track will improve. We'll start actually getting surf like we used to in the old days. And then the rain will start moving into California. Theoretically, all right, it's June, and we're talking about weather in February when I sit there and tell you don't even trust a model 4 or 5 days out. So definitely some rampant speculation on my part right here, but there are clear signs that something is going on. Yes, things could change, but it seems sort of like a dam is breaking or a bulldozer is pushing its way across the subsurface Pacific, and it doesn't seem like that's going to change anytime soon. All right, so let's bring things back to reality. Right now, we've had a little gale in the Tasman Sea. It's produced a small swell that is going to hit actually bigger than small for Fiji, maybe 8 feet at 16 seconds, something like that. But then by the time that swell reaches Hawaii and gets filtered out by a bunch of other islands, it will be small. We're talking waist high or something like that, chest high. Okay, we'll give it shoulder high. For a couple of days of fun surf on the south shore of Oahu. There was also a tiny little gale on the far southeast side of the Pacific that has produced tiny swell. It's going to radiate up into Southern California. I think it's maybe later in this work week. Nothing huge. You can go look at the forecast on Stormsurf and see for yourself. But of more interest, a stronger gale forecast southeast of New Zealand in the next couple of days, Tuesday, Wednesday, might actually generate some real swell for Hawaii and the U.S. West Coast. Hooray, we'll take it. Models hinting that maybe even more is coming behind that. Hooray, we'll take that. And then looking further out, well, you know we're going to suffer through some part of summer and fall for sure, but something clearly is changing subsurface in the Pacific, and we don't think it's going to magically just disappear and evaporate. It might do this thing where it stalls and it sort of does the fakey thing, but eventually it's going to reach Ecuador, and eventually all that cold water on the surface of the equator is going to get wiped out and turn to more of a normal water temperature. 3 months after that happens, the atmosphere above it's going to change. The jet stream will return. We'll be in late fall, early winter by then. And then maybe, just maybe, we'll have a shot at getting a somewhat late winter season, both surf-wise and snow-wise. And that is good news. We actually have, I'm excited, we actually have some good news to report that looks reasonably solid, still a long ways out from happening, but something is in motion in the Pacific, and it will not be denied. All right, if you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Questions, concerns, you don't understand something, send us a comment. We'd be happy to answer. And otherwise, we'll post the link to the video. If you don't subscribe, we'll post the link to the video every page at the top of stormsurf.com, and you can view the video that way. All right, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.